All right, let's keep rolling. Next one. There's your cylinder. And again, I wish I had this shape here. I don't. I have it at school, but we'll talk about it at school, or we'll see it at school. We're now going to talk about a cone. It is similar. It's similar to a cylinder in that there's circular things here as opposed to flat faces. Well, let's compare it to a pyramid. Very similar looking shapes and characteristics are very similar. You'll see there was one base, remember, in a pyramid, and we actually named the pyramid by the name of the polygon that was on the base. A hexagonal pyramid, a rectangular pyramid, a dodecagonal pyramid, whatever. Over here to the right, the base shape is only going to be one of them. That's the same as over here, but it's always going to be a circle. I know you know what a cone looks like, but that is the idea. Always going to be a circle. Now, remember this. This blue thing coming down from the vertex to the middle was the altitude. That is the same thing in a cone. The blue thing coming down from the vertex, and that is called the vertex up there, the actual point of the cone. That's the vertex down to the middle of the base, forming a right angle. That's the altitude. Also called the height of the cone. That's the height of the pyramid. Same concept. Okay? And remember, in a pyramid, it had a slant height. That was the red line right there. From the top down to the middle of the base, forming a right angle. That was a slant height. Same concept applies in the cone, except if you think about how a cone is, there is no, I wish I had a picture. There's no flat part to it. There's no flat faces, so you can't just pick one edge of the cone. But that's what's beautiful about it, because it doesn't matter if you would take it from the right side, or up on the top vertex down the left side, or maybe in the back, or maybe in the front. It doesn't matter. That distance is exactly the same. And they actually call that the slant height. The same as what we do over here. And actually they denote it with a script L. They denote it with a script L. So you'll see that script lowercase l stands for slant height. Okay? Now we also have lateral surface area and total surface area. We'll talk about that here in a little bit. So what I would have written on my foldable if I was you is all these characteristics of cones. And you can write out the definitions, which I already told you, from the pyramid. We already got this on your foldable. So let's roll on to an example. Okay. So pyramid. And comparing it to cone. Here we go. Theorem 114 is the lateral surface area of the cone. It is a weird one, though. I'll tell you that right now. Here's how you find the lateral surface area of the cone. You can't just take and chunk it up and kind of piece it together like you can a pyramid. Because, again, the faces are not flat. They're not triangular faces like in a pyramid. This is just one weird thing. So here's how you find it. It's 1/2 times the circumference of the base times the slant height of the cone. Now, if you notice, I've actually rewritten it as pi r l. How did that come about? Well, watch this. The circumference of a circle is just 2 times pi times r. Now watch. Remember, that's the circumference. So if I take 1/2 times the circumference times the slant height, do you see it? 1/2 times 2 just really kind of cancels each other out, so I'm just left with pi r l. Huh! So these two, I don't care which one. If you're going to ask me which one does it matter, doesn't matter. Depends what's given to you, to be honest with you. Most likely, what's really cool, all you need to do is find the radius, if it's given, or you got to find it, and the slant height. Plug those in, and you're actually going to be done with finding the lateral surface area. There's theorem 114. Okay? Total surface area of a cone. How do you find it? Well, you take the lateral surface area plus, the area of one base. Not two, only one. So now we know this. The base is always an actual circle. So we can be specific, just like we were back in the cylinder. We can be exactly specific and say, wait a minute. This base here is always going to be pi r squared. So there's my formula. Pi r l, that's the lateral surface area right here, plus pi r squared. That thing right there is your exact formula. Sweet. So that should be going in your foldable, no doubt. So here I have an example. I have the radius of this thing is 6. Ooh. Let's just do this. This is 6. The slant height happens to be 8. Whoops, that's not right, sorry. The actual height. The height, it says. So that's this piece, the height. That guy's actually 8. So the question is, what's the lateral surface area and what's the total surface area? Well, the lateral surface area, I have pi r l. That's my formula. Do I know the radius? Check. I do. 6. Do I know the slant height? Check. Whoop. Careful. I don't have the slant height. That 8 is not the slant height. It's the height of the cone. Be very careful in those. So how do I find the actual slant height? Well, oh, right. Remember, the altitude forms a right angle. So all I really have right here, guys, is nothing more than a right triangle. And I have one leg is 6, the other leg is 8, therefore this has to be a 10. It's a 6, 8, 10 triangle. Lovely. So 10 is my slant height. I plug that in, so pi times 6 times 10 gives me 60 pi unit squared. Actually, I wouldn't put unit squared, I put this. I put centimeter squared. Centimeter squared. Lovely, okay. So there's my lateral surface area. All I got to do now is find the actual area of the base circle. Well, that's pi r squared, which would happen to be this over here. Pi r squared. The actual radius itself is 6, so that's 36 pi. So that right there is the area of the base. I'll take that and add it to the lateral surface area, which was 60 pi we found earlier. And the answer, the final answer, would be 96. This is wrong too. I'm going to change this. It would be 96. Hopefully you can see this on the video. 96 pi centimeters squared. And there you go. So that is the cone, and we just talked about the cylinder. So make sure you memorize those formulas, kiddos, because yeah, you'll need to make sure you know those and plug in the numbers, the radius, the slant height, the height, the diameter, whatever they are. They can get very confusing unless you take the extra time to study these formulas and memorize them. So we'll see you in class. Looking forward to practice them. Later.